X is real number and 4 to the x plus 8 to the x equal to 2. Find the value of. So here 4 and 8 are related. We can consider 2 to the x as basis of these two things. We know that. Let's write at first the equation 4 to the x plus 8 to the x equal to 2. And now they are related to 2 to the x. By power rule, we know that a to the n equal to a to the mn. And I know 4 to the x equal to, instead of 4, I can write 2 squared to the x. So we can replace them because by power rule, it is m and 2x. I can write 2 to the x to the 2. So I want to use changing variable. I consider 2 to the x equal to y. So by my definition, it will be y squared. And let's consider 8 to the x. 8 to the x, 8 is 2 to the power of 3, 2 cubed. The x, we can also write it as 2 to the x cubed. Because 2 to the x is y, it will be y cubed. Now I use these two things. 4 to the x equal to y squared and 8 to the x equal to y cubed. So I write here y squared plus y cubed equal to 2. Then I take all things to one side. I say y cubed and switch only the places of them. This y squared minus 2 equal to 0. This is a cubic function. The most useful way is to find at least one root. If y equal to 1, you will see 1 cubed plus 1 squared minus 2 is 1 plus 1 minus 2 is 0. So y equal to 1 is one root. Now, because y equal to 1 is one root, we can factor. It is so much useful. The idea you can factor from y minus 1. I want to create y cubed plus y squared. So minus 2. I place y squared, it will be y cubed minus y squared. I want to reach plus y squared. So I should place 2y here. Now I have 2y squared minus 2y. Y squared is okay, but here I don't have 2y in my first main equation. So for canceling negative 2y, I place 2 here. It will be plus 2y minus 2. And it will be equal to 0. Now here we have two cases. The first one is 0 or second term is 0. If we analyze both of them, so let me write case 1. Y minus 1 equal to 0. So if it add plus 1 to both sides, y equal to 1. Y was what? By changing variable here, we conclude 2 to the x equal to 1. So we conclude x has to be 0. One answer here that we found. Let's check the other case. Case 2. The second term, y squared plus 2y plus 1 equal to 0. I will solve this with two ways because in some problem, solution number 1 works. In some problem, solution number 2 works. So solution number 1 for this part. I can use this identity that a plus b squared equal to a squared plus 2ab plus b squared. So you should memorize this. If I place y instead of a and 1 instead of b squared, it will be y squared plus 2y plus 1 squared, which is 1. So here I can say, oh, sorry. This part, let me correct. This part is y squared plus 2y plus 2. I should place 2 here. Now I say, okay, we can say y squared plus 2y plus 1 plus 1. I divide 2, split it up to 2 ones equal to 0. Because of this, I can say it is y plus 1 squared plus 1 equal to 0. So I can say y plus 1 squared. If you subtract 1 from both sides, negative 1. But I know y plus 1 squared, this is square, so at least 0, but it cannot be equal to negative 1. So contradiction. It was solution number 1, and we've used this identity. Let's work on solution number 2 in Solution number 2, I want to use quadratic formula. If I have a function that is ax squared plus bx plus c equal to 0, we consider discriminant, or someone called it delta, equal to b squared minus 4ac. If x is real number, then it has to be at least 0. So in the problem says x is real number, so y is real number because y is 2 to the x. And here, if we analyze that, y squared is 2y plus 2 equal to 0. A here is 1, B here is 2, C here is 2. And delta, or discriminant, equal to B squared 2 squared minus 4AC, which is 2 squared 4 minus 4 times 1 times 2, 8, negative 4 less than 0. As discriminant is less than 0, so with also solution number 2, we've proved that we don't have any real answer here. Please don't forget to subscribe, like the video, and turn on the bell for having next videos. Thanks.